Okay, we are picking up on 10.4, finishing the isometries. So just the one. All right, example 3 is already done for you, which was helpful because it actually ended up being 15 and 17 from your homework last night.
See, that looks so different than what we would have done on 15 and 17.
Not really.
Why does it look that way?
Oh, wait, hold on. Let's see. Find the line of reflection. And it is different. I'm sorry. It is different. I was like, I did right. Gave you the right thing. So example 3, but it is done for us so we can kind of see. It says, find the line of reflection in a translation vector that define the glide reflection mapping of triangle ABC to congruent triangle A prime, B prime, C prime. So first, got some help there for you. The line of reflection passes through the midpoints of the segments connecting each point image pair. Right, so if we wanted to do this, I'll give each of you a ruler here. Yes, you can have a pink one. Okay, then I'll take the green one. Okay. So you do a point image pair. So that's what they're showing here, right? And so B, and you don't, I was like, you can just measure it. So they're kind of measuring B to B prime is about 2 inches. So from B, point B, let me use a pencil here. From B to B prime is 2 inches. So the midpoint would be about 1 inch. And so I need a smaller ruler here. All right, let's pause for prayer and then we'll continue. Okay, Lucas, your turn. Oh, I didn't pause the video. Thank you. Okay, so and you can see on the other one, so 1 to 2, and they've marked the midpoint at 1. Okay, so that's what it's saying is the line of reflection passes through the midpoints. So then they do a line of reflection at points A. So they measure the distance between A and A prime, and then they mark the midpoint because this is about, okay, so we have, how long is that line, would you say?
Yeah.
Yep, doesn't count, right? You can,
2 and 3/8.
2 3/8 would be way over here.
No, 1 and 3/8.
1 3/8 would be 1, 2, 3 here.
It would just be 3/8.
No, 1. No, or so I'm saying this line across here. How long is this line? 1 5/8. Okay, so then we mark the midpoint here, and they drew the line of reflection. Okay, so they're more specific than what we were in our homework. Now it says, then reflect an image point across the line of reflection to find the terminal point of the translation vector originating at the corresponding pre-image point. So we're trying to go backwards to get this. In your homework, you were given one part, right? You were given an image on 15 and 17, and then you were given the vector to sketch. Now you're given the pre-image and the final image, and you have to find where the image before was at. Does this make sense? Okay, so we're looking for the intermediate image. So what that's saying then is reflect an image across your line of reflection. So to do that, we would measure and say, okay, now that we have our line of reflection, how far is B prime from our line of reflection? So it's about, how long?
7/8.
Do you guys agree with 7/8?
6/8. I can't see where you're pointing to.
Where my pencil is, right here. Right here.
Okay, that would be.
So 1 is over here. I'm looking right here.
6/8.
Okay, those tiny ones aren't eighths. Those are 16ths.
Oh,
The eighths are the...
I didn't know that. I didn't know. So 13/16.
Okay, so 13/16. So what they do is then you come over here and you would go 13/16 as well. Okay, measure 13/16 from your line of reflection straight over, and you would put a point for your B to reflect it. Okay, and then you would do the same thing for C. You would measure how far C is from your line. Okay, and then you would go to the other side and you would measure it over and you would put a point to draw your intermediate point. Does that make sense? Okay. All right. I'll leave that with there, I suppose. Then example 4 kind of gets into the fun real world example. So it says find the point on side 1 at which a golfer should hit the ball to bounce off side 2 and make a hole in 1. Draw the intended path of the ball.
Oh, I already know it.
Okay.
Where you just like hit it against the wall where it goes into H.
You would hit it against the wall, not to where it goes into, yes, but it wants it to find the point on side 1 at which the golfer should hit the ball to bounce off of side 2. So it has to, from the tee, you want to hit side 1 and hit side 2 and then hit the hole. But here's the thing. Nope. There is geometry to this. It is about glide reflection.
No, bro, it's right there.
I know, right? You think. Okay, so draw the intended path. So it's telling us how to do that. So we want to reflect H, okay, the hole, inside 2, and we're going to name it H prime. So how do we reflect it? Move it over. Okay, so what are we reflecting it across? What line?
Side 2.
Okay, side 2. So I'm going to use the centimeters, the millimeter sign. It's a little bit easier. Okay, so from side 2, my hole is like 8 millimeters, 1 off of 1. It's in between. I guess you could call it in between 8 or 9. You could call it either. Okay. So then you need to go to the other side. So you could line that up in between the 8 and the 9 and put a point, and that's your H prime. Okay, so we went an equal distance from here to here. So that was 8 millimeters, and we're going another 8 millimeters away to reflect it. Does that make sense? Okay, now we want to reflect. Step 2 says reflect H prime inside 1. Well, I'm going to extend, this is my side 1 down here. I'm going to extend it a little bit so that I can reflect it a little easier. Okay, so if I'm reflecting H prime in line 1, I need to measure that distance, right? From H prime to side 1, and I have about 2.1 centimeters. So you can move it down, or from here you could say, well, what's 2.1 plus 2.1? So you could go down to 4.2 and make your mark. Either way, because this is 2.1. So this was centimeters, and we went down another 2.1. Okay, so this is H prime prime. So we're quite literally thinking outside of the box here. Ha, 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 ha.
And that's why you're a dinosaur.
It's true. That's why I'm a dinosaur. Okay. So you have H1 or H prime and H prime prime reflected. Okay. So now it says nope. It says now draw T to TH prime prime. So draw segment T to H prime prime.
I know what you do now. Hey, that's where I have my line to the wall.
Okay, and then draw X. We were supposed to label that, sorry. That intersection X.
Yep.
This point is X. That's where it's going to bounce off of side 1. Okay. And then we do this to H prime. Because then it's going to hit side 2 on its way to H prime. And we're calling that Y. And so then from Y to H is the path of our ball.
I think I already drew that path.
So our path would have been T to X, X to Y, and Y to H is the path of the ball.
Yeah, that's what I drew.
Sorry, I got off there. You might have, I mean, that's the thing, like, right? You innately have an idea. Okay, it's like playing pool, mini golf, any of those things. You know you can't hit the ball straight, and get it into that hole from where you are. You know it has to hit off of the wall, and then you have to try to get it there. But that's the thing, is there is geometry behind these topics. And in this case, it comes down to reflections and then moving the ball.
When Mrs. Moore threw a paperclip at me, you think she used geometry?
Shh, was she mad at you?
Yeah. No, she wasn't mad at me. She's like, stop it, and like threw a paperclip at me, and like I did the matrix to dodge it, but like it almost hit me in the eye. It almost broke my eye.
She probably didn't think about it that much.
She doesn't think.
But you know, like if you're, I was trying to think, like there's a game that you play where you have to like when you go to the fair maybe, and there are bottles there, and you want to ring the bottle, or you're supposed to get the ball into a certain place, like when they play the cup game and you're supposed to bounce the balls and get into the cup. Those are all geometry. Granted, you're doing the like, for you to do them, you're doing the calculations in your head and like thinking, well, where do I want this ball to hit? But it all comes back to shapes and geometry and how they interact with each other. So it's pretty cool. All right, then your homework then is to finish up what we didn't finish last night. So we stopped at 17. So 19 to 23 odd, and number 37, which you have that worksheet for to help you.
We don't have to do our homework anymore, so.
All right.